All right, class, we're going to talk more about functions today. This is still 1.3, just day 2 of it. So the first thing we're going to talk about is how to figure out if a function is even or odd algebraically. And all you have to do is input negative x into f of x. When you do that, you'll get 3 possibilities. If when you input a negative x into f of x, and you simplify it, and you get the original function out, then the function is even. If you input a negative x, but then what it does is it changes the sign of all pieces of the function, so all of the function has changed signs, then the function's odd. Now, if you get like half of them changed signs, half didn't, so if neither happen, then it's not even or odd. Okay, so let's see that in practice here. So we're going to do that for the next couple. So again, pause if you need to copy that down. So all you have to do for these problems is input a negative x into f of x, for x. So what I'm going to do is say f of negative x equals, that x turns into a negative x, minus 2 times negative x cubed. Now whenever you raise a negative to an odd power, it stays negative. So we get negative x to the 5th, that stays negative and comes out, plus 2x cubed. So here's my final answer now, after I simplified it. And if you compare it to the original, you should notice that the x to the 5th changed signs and the 2x cubed changed signs, which means that when we put this in, we ended up with everything changing signs, which means that, therefore, that's what those 3 dots mean, the function is odd. Because both of them change signs. Alright, let's do it again over here. Put a negative x in. So we get the square root of negative x plus negative x squared. So when we simplify that, we get the square root of x plus x squared. So this one did not change signs. However, this piece did change. So this probably is neither then. Okay. All right, let's go on to this one. If you put a negative x in, you put it in where you have x's, and if you again notice that this is raised to the 4th power, this is raised to 2nd power, both of these negative signs will then go away, so we're left with 9x to the 4th. That is still there, minus 3x squared plus 7. And if you notice, that's equal to the original. So when you get the original out, that means the function is even. All right. If you want to try this one on your own, you can pause it before I go, but I'm going now. So it's 1 plus negative x quantity squared plus negative x quantity cubed. This negative sign will go away. This negative sign will not go away. So if you look at the final answer, the x cubed part changed, but these did not. So again, this is neither. It either all has to change or all stay the same. These signs have to either all change or all be the same. All right. Next, we're going to excuse me. Okay, next we're going to be using our calculators to graph it over the interval, which means set your window. This is your x min. That's your x max. I'm not going to do that on here because I want to save time for the video, but that is what you will be graphing. Okay, And if you graph that, it will look, I'm going to put that up in a second. Hold on one sec. Okay, so here it is now. So if you need to write all this down, you can pause the screen real quick. But this is what I saw when I graphed it on my my calculator. And I got that this point here was -1.7, and this point here, I call point B, is 1.3. Again, the A point is a local max because it's higher, or relative max, if you want to call it a relative or local max. A local min is the same thing as relative min. Again, on your calculator, to get that point, you would have to go to second trace max and then bracket it, or second trace min and get that. Again, I assume you've done that before. If not, you can I'll talk to you about it in class. And then we have to say where it's increasing or decreasing. So if you notice, this little interval it's increasing, that interval it's decreasing, this interval it's increasing. So increase would be from, we're starting at -2, we're going to -1 in the x, and b starts at 1 for x, and then our final window goes to 3. For decreasing, the x value for a is -1, and the x value for b is 1. So that would be that one. Okay, I'm going to quickly put the other one up now. Okay, you should have seen on your calculator that you would have a graph like this. Again, set this as your x min and this as your x max. And then all we have to do here is find the places where it's increasing and decreasing, just like the last one. So hopefully you guys can see that it increases, decreases, and then increases again. So let's write down those intervals. Again, we're only looking at the x values when we do interval notation. For increase, it starts at -2 because that's where our window starts, and goes up to point A, which has an x value of -0.77. And then we union that with point B, which starts at 0.77 for x, and we end the graph at 2. So those are both our intervals that are increasing. For decreasing, there's just one interval between A and B, so between these two x values. So we have -0.77 up to 0.77. So that is doing interval notation with increasing, decreasing, and hopefully, like I said, I will help you guys out with graphing if you need extra help. I just did not want to do that on this video because I assume you guys know how to graph by now. But if you don't, come in and get help. Alright, so now the last thing we're going to talk about is average rate of change. Average rate of change is pretty much slope. Okay, for these problems, we're going to write it down as the function at one point, so f of b minus f of a over b minus a. That is what we are going to use for average rate of change, where the b and the a are the x values. So this would be a is -3 and b is 2. So let's see what happens. So I'm saying the average change is equal to f of 2 minus f of -3 over 2 minus -3. So in order to do these problems, you have to figure out what happens when you put a 2 into this function and what happens when you put a -3 into this function. Well, I'll do those here. F of 2 is 2 cubed minus 2 times 2 plus 1. So that's 8 minus 4 is 4 plus 1 is 5. F of -3 is -3 cubed minus 2 times -3 plus 1. So let me think that through real fast. We have -27 plus 6 makes it -21 plus 1, which is -20. So now we can say the average change, average rate of change I should say, I'm just writing it with shorthand here, is f of 2 is 5 minus f of -3 is -20 over 2 plus 3, because those signs change. So we get 5 plus 20 is 25 over 2 plus 3 is 5. So the average rate of change during that interval on the graph is 5. And what that means is, if you were to graph this on your graphing calculator and you would connect the dot on the graph from x of negative 3 to x of 2 and draw the line, it'll have a slope of 5. Okay? Now what's nice about this next one is we already know what f of 2 is. So we know f of 2, well, first of all, I'm going to do it again where we have f of 5 minus f of 2 over 5 minus 2. Again, we're doing slope. The y value when x is 5 minus the y value when x is 2 over 5 minus 2. So the thing I need for this problem is f of 5. So to do that, we get 5 to the third minus 2 times 5 plus 1. This is going to be very big. So that's 125 minus 10 is 115, plus 1 is 116. So the average rate of change is equal to 116 minus, if you look back at the other problem, we had a 5 for f of 2, and then over 5 minus 2. So we get 111 over 3. And I believe, that should be fine if you want to just leave it like that. Actually, that divides nicely, never mind. So this would actually equal 37. So the slope between 2 and 5 on the graph is 37. And in class, I'll show you that. Okay, so that's it. That's how you do average rate of change. And even and odd is very important algebraically. And then the third thing we did was graphing and finding where it increases and decreases. All right, and that should be it before your quiz. So hopefully you guys understand, watch these videos again for extra review, and come in for help if you have any questions before the quiz.